Hello guys, welcome back. So in this video, we will be solving Leetcode fourth problem, divide an array into subarrays with minimum cost second. Okay, so pause the video, read the question, then we'll proceed. Cool. So in the question, it is given that we will be given an array of integers nums and two positive integers k and dist. Now, what we need to do is, and there's one definition of cost. So, like if there is an array, the cost of that array will be nothing but the value of the first element. Okay. So, if like there is an array 1, 2, 3, its cost will be the first element, that is 1. Similarly, if we have another array like let's say 3, 4, 1, then its cost will be the first element, that is 3. Okay. Now, afterwards, we have been given that we have to divide nums into k disjoint continuous subarray. Okay, so what is this k disjoint continuous subarray? So it is nothing but we have to divide our array into subarrays, contiguous subarrays, such that they are non-overlapping. So let's say if we have this kind of array, so contiguous and disjoint, there are two terms. So disjoint, that means there will be no overlapping. So this is one subarray. We cannot take another subarray consisting of this common element. Okay, so that means we have to make it disjoint. So disjoint means we'll have to take another array such that this element is not common. So let's say someone says that we can take from here, but it is also mentioned that it should be contiguous. So the next array you can next subarray you can take only from here. In the same way, let's say we take in here, and again let's say the last array is this one. So our question is, we have to divide this nums array into k disjoint contiguous subarrays. Now there is one more condition, that the difference between the starting index of second subarray and the starting index of kth subarray or the last subarray should be less than equal to this, like the one constant or the one integer we have been given in the start. So what does it says? It says that let's say if we have an array like this one, now we have to divide this into k subarray, k contiguous disjoint subarray. So we know that the first subarray will always be this one. This will be the second until let's say this is the kth subarray. Now, what the question says is that this index, whatever this index we have, and this index, whatever we have. So, like it's a subarray 2, or let's say starting as I2, and this is let's say, or it's better in the question it is given from, see, in this way, that this is a subarray, so it will be 0 to I minus 1. So, in that subarray, what it will be I1. Okay, like this is the starting position is the I1, and let's say its starting position will be ik minus 1. Okay, so the difference between ik minus 1 and I1 should be less than equal to this. That is nothing but this starting index or the starting index of second subarray minus and if the difference is taken from the starting index of the last subarray or the kth subarray, the difference should be less than equal to test. Okay, now, so when we will divide this into k subarrays, right? So let's say this is the one, this is the second one, and so on. So the cost of each subarray, we know the what is the cost. Cost is the first element of any subarray or any array. Okay, so we have to keep the minimum sum, or like we have to, or minimum possible sum of this cost. So we have to divide this array nums into k disjoint contiguous subarrays, such that the cost is minimum possible, or the sum of this cost is minimum. Okay, so I hope the question would be clear. Let's see an example, because someone complained that, sir, please explain some examples as well. So let's see if this is the subarray, right? And k is 3. So this is the given array, k is 3. That means we have to divide this array into three parts. Now this is 3. So that means, so let me do one thing. Let me copy this one. 132642. 132642. K is 3 and dist is also 3. Okay. So k is 3, dist is 3. Now we know that the first subarray will always start from this 0, right? Now the second subarray can start from here, like anywhere. Oh, sorry, let me number it. It will be the indices 3, 4, 5. Okay, so let's say if second subindex or second subarray started from here, that means that means the I1 we talked about in this question, or the starting index of the second subarray is 3. And we know that whatever the final subarray, that is ik minus 1 minus I1 should be less than equal to dist, and here dist is nothing but 3, right? So it can be 3. I1 is also, let's say, sorry, here I1 would be 1. My mistake, I put it the value over here, it will be I1 will be 1. So if I1 is 1, then ik minus 1 will be nothing but 3 plus 1, because here it is minus 1, right? So it will shift that side, and ik minus 1, it should be less than equal to 4. What does that mean? That means the starting index of the last subarray can go till here if we select this one. Okay, but let's say if we selected this starting index, or I mean, what does I mean to say, let's say if this is our first subarray till here, then the second subarray started from here, then in that scenario the last subarray can start from this last index as well, from the fifth index. Why? Because this is 2 and 2 plus 3 is 5. Okay, so I hope that part would be clear. Now let's see one thing. So if we are at this place, right? If we are at this place and considering the same scenario where k is 3 and dist is 3, we know that we can take till here, or we can start the last subarray at least till from this fourth, or like the element with fourth index. Okay, now so one subarray, what we can do is, so let's say, sorry, in this scenario it will go till here, right? If we are starting from this 2. Okay, so let's say if we have this subarray, right, the first subarray. Now we know that in this remaining part, we know that the second subarray should start from here, and the last subarray, or the kth subarray, should start from here. In this scenario, the kth subarray is nothing but the third subarray. So the first subarray is here, second subarray we have to start from here, and third subarray we can start till here, but we can also start from here or here. So let's say if the second subarray just contained one element, then our third subarray, what will happen? The last subarray or the third subarray will contain all these three elements. Okay, so in that scenario the cost will be what? This 1 plus this 2 plus 3, and the value over here is 6. So 1 plus 2 plus 6, that is 9. So in that scenario 9 will be our answer for this particular partition, right? But let's say instead of doing this, let me rewrite this again. 1 3 2 6 4 2. So instead of selecting these two elements, I selected just first element as the part of the first subarray, or this entire first subarray. Okay, now the second subarray I need to start from here, and let's say I started till here. Okay, or sorry, it will become the second case, right? Let's say I extended the second subarray till here, and the last subarray will become this one. So in that scenario, our cost will become 1 plus 3 plus 4, that is equals to 8, which is better than our previous solution. But can we do still better? Can we still do something better than this? Okay, so what we can realize is, or let's see one more example. So in this scenario, let's say if I select first and 3 as first subarray, 2 6 4 as second subarray, and the last 2 as third subarray. So in that scenario we can have 1 plus 2 plus 2, which is 5, and this is the best answer. We'll see our example, this is our answer as well. Okay, so this is the best possible, or the minimum possible sum of the cost. Okay, now if we'll see carefully what exactly we are doing, so let's say if this is the array. Okay, this is the array. We know that first the first subarray should always start from here. Okay, now we have to choose k minus 1 points. Okay, so we have to choose k minus 1 points. Why k minus 1 point? So let's say if we needed k subarrays, right? K subarrays, so we have already chosen the first starting point. Then let's say if k value is 3, then it will choose two more starting point, let's say here and here. Then in total we'll have 3 subarrays, right? So this will be the first one, here to here second one, and here to here the last one. Okay, so listen carefully what I'm trying to say. if we have to choose k subarray, we know that the first subarray should always start from this first index or the zeroth index, sorry, zeroth index. So we need to choose the k minus 1 indices, k minus 1 indices. Now we have to always keep in mind the constraint that the first index will be choosing and the last index we will be choosing. Like here in case we have considered the 3, but let's say if it was 4, so the last index, let's say we consider something like this is another subarray and this is the last subarray. So if this is I2 and this is ik minus 1, sorry, ik, it would pick up if we are numbering from 1. So we know that ik minus I2 should always be less than, sorry, ik minus I2 should always be less than equal to this. That is known. Okay. Now, so if we consider this something like this one, that in this given array, this is our first index. Now it will extend somewhere here, we don't know exactly where it is going, but somewhere, let's say we can start from here, we started from here I2, or better, let's consider that this this first subarray only consisted of one element. Okay. Okay. Now what we can do, if we start from here, if our I2 is here, then I can go till this subarray, sorry, this till this starting point, or whatever element index it would be, and it will be nothing but I2 plus dist. Okay, I2 plus dist. Now if you'll observe carefully, here we have one observation, that in this subarray we have to choose k minus 1 points or k minus 1 elements. And what will that will be, that will be nothing but the starting point of the k minus 1 subarray. The first one is here, and if we'll choose k minus 1 subarray, in total we'll be choosing k subarrays. So listen carefully, what I am trying to say is, if this is the I2 is our starting point, or the starting point of the second subarray, because first we have already chosen, then the last starting point would be I2 plus dist. Now if in this I2, let's see that here to here, it was the starting point was I2, and it is I2 plus dist. Okay, and there are four more elements on both ends. Okay, so we selected this one as the first, or the starting index of the second subarray. Then we'll have to select one more, then we'll have to select one, how many, k minus 1 times. So this is the first, second, third till k minus 1 times. See, we know that for any subarray, what is the cost is the first element, right? Cost is the first element. So if we are saying that we will be selecting k minus 1 points or k minus 1 indices, then how should we select it, so in total there are dist element, right? Here to here we know that there are dist elements. Okay, and out of this dist elements we have to select how many elements, k minus 1 elements. Why? Because we need to select k minus 1 subarrays, right? So if we'll select k minus 1 starting points, then we will have k minus 1 subarrays. You don't need to worry about if it is extending here, okay, or if there is a first subarray coming till here or coming till here, because it doesn't matter to us, right? Why? Because if we select, let's say, the first subarray till here, then also its cost will be this first element. If we select till here, then also the cost for the first subarray will remain the same, that is the first element. So let's say in this range, or out of this element, if we have to select k minus 1 elements, what we are saying, that all these elements on the left will become part of this first subarray, and all the elements on the right will become the part of the last subarray, whatever will be selected. So in a nutshell, what or what is our requirement, that out of this dist elements we have to select k minus 1 element, such that the sum of that k minus 1 elements is minimum. Okay, I'll repeat again. So what I am saying is, we have to select elements such that the first index or the starting index of the first subarray, or in technicality the second subarray, because first subarray we have already started from this 0. So the second subarray and the last subarray. Okay, the difference between those starting indexes of both these subarrays should be less than equal to dist, right? So that means if we are selecting any index I, then the last index we can start from is I plus dist. Okay, and from in between these dist elements, we have to select how many elements? K minus 1 elements. So question is very simple now, that out of this these elements we have to select K minus 1 elements. Okay, I hope till here everything would be clear. Now how we can do it? So it's very straightforward solution. We'll have just two multiset. Okay, one more thing. So let's say if we started from first position. If initially if I was first and let's say this was 7, then we would go something like till 1 to 8, right? But if we'll increase this 1, then it will become 2, and then in that scenario this will become 9. So our array will be, or our subarray, or the interval we have to select from which k minus 1 elements will become this one. So you can see that this is nothing but kind of sliding window problem. Okay, फिर again if we'll move this our left pointer, then we'll can we go to this one more element on the right. So what we can see, that if we are from 1 to 8, or like basically the starting indexes was I, then till I plus this we can have all the elements. Out of all those elements we have to select k minus 1 elements, right? So there were dist elements, and out of this dist element we can select k minus 1 elements or the minimum k minus 1 elements. Okay, emphasizing, I'm again emphasizing why, because in the question it is mentioned that we have to return the minimum possible sum. Okay, so that's why we will select this minimum k minus 1 elements from all these dist elements. Now if let's say initially we are at 1 and we have this window, right, 1 to 8, when we are shifting from 2 to 9, then we'll have to remove this element whatever we have at the first, and then we'll have to remove this element, sorry, add this element whatever we have at this index 9. Now as we know that out of this element we can select only k minus 1 element, so what we'll do, we'll have two multisets. Okay, two multisets. What one will do, one will do the current selection or the k minus 1 elements. Okay, k minus 1 elements, and the another one will keep the remaining elements. So if this is the current, and this will extra, or the remaining elements, whatever you want to say. So in total, if we'll take the sum of the sizes of both these multiset, that will become equal to dist. Okay, so so now if what we'll do in the starting, like 1 till dist, we will add all those elements in the k minus top k minus 1 element, or the minimum k minus 1 elements in this, and the remaining on this one. Now for the initial we have our answer as whatever the sum we have at this current. Now whenever we want to add new elements, right, whenever we want to add new elements, let's say we want to add 9, then we'll have to remove 1. Now let's say there are possibilities that what can happen, that let's say if at one, like let's say if it was index 1, right, it was index 8, 9, 10 and so on. So at 1, let's say here it will be 0, at 1 it was 5. Now there are two possibilities, that this 5 can be a part of our k minus 1 elements, or it can be an extra. Okay, but sometimes it may be in both, like here also, because let's say if there was 5 here as well. So what should we do, should we remove from here or here? We should always move from the extra element. So first of all, what we'll do, we'll try to see if this 5 is present in the extra element, then we will remove it. But if it is not present, see, it is mandatory that we will need to remove this first element if we want to take this 9, right, or the element at the ninth index. So we must need to remove this first element. So first of all, if we'll check, if it is present in extra, then we'll remove it here, nothing will change. But if it is not present in extra, we'll have to remove it from here. Now now let's say we removed our element. Okay, for the removal we have our logic clear, right? I'll repeat again. First of all, we'll check in the extra. Why? Because we know that in this extra all the elements are greater than all the elements we have in this one. Maybe they can be equal elements, but ideally there will be all greater elements. So if there is 8 here, 8 here, it doesn't matter whether you delete this 8 or this 8, we can simply delete from here. Okay, now while adding, maybe here, let's say if we are deleting 5 and we have deleted from here, let's say there is possibility if there is 10, then how, then maybe let's say there was 6 present in the extra element or the extra elements. Okay, so if 6 is present in the extra element, we should choose this 6. But if instead of 10, let's say here it was 1, then we should have chosen this one, right? So what we will do, whatever element we have at this index, first of all we'll insert this in this extra elements, and then as it was a multiset, it will get automatically sorted. So we can simply choose the first element because this will be the minimum, and we can push it into this. Now remember one thing, as we have the sliding window, right? So we will have a sum of all the elements. So whenever we will be inserting anything into this, we will be adding its value to sum. Whenever we are deleting anything from this current multiset, we will be subtracting that from our current sum. And finally we can have our answer as something like this. Answer is minimum of sum comma answer. Okay, so I hope this would be clear to you. I will repeat again. So what we need to do is, it is clear that we have to select a window of size dist. Okay, and out of this window we have to select k minus 1 minimum elements, or the minimum k minus 1 elements if it is in sorted order. Okay, or the first k minus 1 elements if it is in the sorted order. Okay, now how can we do that? We can maintain two sets. What, yes, there is one more important question that I will leave it to you guys. So why are we not just using some kind of priority queue and we're maintaining the size of k minus 1? Okay, let me know if you know the answer. But if you still don't have the answer or explanation for that, ask me in the comment section. Okay, so now we know that we'll have to maintain two arrays, two multisets. One is the current k minus 1 elements, and then one other one is the remaining elements. Why? Because this can be greater than k minus 1, right? So, and whenever we'll delete anything, we'll delete from here. Okay, I mean ideally it won't matter, even because if this element is also presented here, we will, even if we will delete from here, nothing will happen. Okay, because whenever we are adding element, we will be pushing it to the this extra elements, and then whatever the minimum element we have, we can simply push it over here. So overall it won't affect whether you are deleting from here or here. Okay, so then whenever we are adding any element to this is current multiset and this is extra multiset. So whenever we are adding any element to our current multiset, we'll add that value to our whatever the current running sum we are taking for this current elements, and whenever you are removing anything, we'll subtract it. I hope the logic would be clear. Now let's go and see the code. Just a second, guys. Sorry, this one. Okay, see now. So as discussed in the solution, we have taken two multisets, this current and extra. First of all, I did, I selected the first dist elements starting from the first index. Why the first index? Because we know that the zeroth index will always be reserved to start the first subarray, right? Okay. So first of all, we put it all the elements, and now out of all these dist elements, what we have to do? We have to take k minus 1 minimum, or like the minimum k minus 1 elements, right? So that we can simply take, like, as this was a it was a multiset, that means it will be sorted in ascending order. We are just pushing the k minus 1 elements in our current set, and at the same time we are removing from this extra. Okay, and we are increasing our sum because we already discussed, right, that if you insert anything in this current multiset, we'll add it to our current sum, or the sum. Okay, now initial answer can be this sum because we are taking the first k minus 1 elements. And yes, you guys might say that we are missing the zeroth index, but no, we are adding it in the last. Okay, so now as discussed, the sliding window starts from here. First of all, we will check which number we have to remove. Then we'll find if it is an extra, we'll remove it. Else, when if we are removing it from the current, then we'll find it, we'll remove it, and then we'll decrease our sum. Now, if we have removed from, let's say, extra, that means our size is not decreased for this current. Okay, but if we have removed from this one, then our size would be decreased. Okay, now let's say, as discussed, which number we should add now. Okay, so we will push that number in this extra, and now extra is a multiset, so it will become automatically sorted again. So we'll pick the first element, we'll add it to the sum. Why? Because we are going to insert it into our current multiset. Okay, now then if we have inserted that element into current multiset, that means it is no longer present in the extra, so we'll have to remove it. So that's what we are doing, we are removing it. Okay, now if the current element or the current multiset size is less greater than k minus 1, what does that mean? That initially we would have deleted from this extra, and now we have k elements instead of k minus 1 element. So in that scenario we'll delete one element from our current and we'll push it back to our extra. Okay, so that's what we are doing. We are taking out the last element. See, this is r begin, so it will give the last element or the reverse beginning. So it will start from the reverse or the end, whatever the first element we have, it will be given by this r begin function, and obviously you know the asterisk given its value. Then we are decreasing that from the sum and removing from the current multiset and pushing back to the extra. Now finally at this point, whatever we have in this sum is nothing but the sum of the k minus 1 elements, which are the minimum k minus 1 elements, right? And we finally updated our answer. And finally, while returning, we must remember that we have to add the num 0. Why? Because we know that the first subarray will always start from the 0. That's why in our whole discussion we have always started from this first index. Okay, first element leaving the first element reserved for the first subarray. Okay, so we can finally return the answer. Let me submit. Okay, so it's an accepted solution. I hope everything would be clear to you, but if you guys have any doubt, ask me in the comment section. Okay, thank you guys, see you in the next video.